So taking this a step further, we've really squeezed out all of the optimization that we can get down to 28 nanometers. And at this point, the actual algorithm SHA-256 can't be optimized really not much more, and certainly not orders of magnitude more. And so we're locked into Moore's law. So from this point on, it's really about chip density and access to fabs. But the other interesting effect that's happening is that now the density of the chip can't change, but the number of chips you can put within an enclosure, your ability to dissipate heat and feed power to it, has pushed this game into the realm of high-density data centers. So things like liquid cooling are coming back. We're seeing these 19-inch, 4-unit rack-mountable hashing rigs that are even going to push the limits of data center capacity with 25-kilowatt racks and high-density, high-thermal output situations, which again makes it a much, much more specialized function, a much more specialized industry, which requires large capital investments as well as skills and personnel to manage. Essentially, now there's a building that comes with it that's wrapped around this hashing infrastructure, which is the data center and its cooling and power facilities. Do you see that as an additional danger for centralization?
Yeah, so that clearly is a danger for centralization. At the beginning of your comment there, you mentioned as the ASICs were introduced, they were in a process of catching up with Moore's law. So we've got a kind of S-curve that's terminating in Moore's law and then following CPU technologies. But actually, talking with some ASIC mining vendors yesterday, I'm surprised to hear that they're actually shipping 20 nanometers first quarter next year, which may mean that they are actually surpassing CPU vendors in being the first to produce the next generation from 28 nanometers on the TSMC line. So it may be, which is a kind of amusing situation, that there's actually more economic incentive to push harder and faster to get to 20 nanometer and 14 nanometers for ASIC miners than there is actually for CPUs. And actually there are some advantages that ASIC hashing has over CPUs in terms of simplicity, because you don't really care so much about error rates, because you have many, many hashing units, and if some of them fail, you just disable them. So they can probably tolerate higher error rates. They can adopt earlier technologies when the error rates are higher. They can push the limits harder and still get very useful function from ASIC hardware.
So we should be paying attention to the ASIC market as the new front runners of Moore's law. That's and all of the economic incentives have pushed us there.
Yeah, I mean it's a kind of a curious situation, but that seems to be what's happening if the ASIC mining companies are able to deliver on their projections.
So just a quick clarification here. We're talking about centralization, and some people confuse this as a concern about someone being able to mount a 51% attack. For me, this is a much simpler problem, which is that every single feature development or change in the code or other modifications of the core Bitcoin protocol has to go through a process of consensus and adoption by the miners. And by having a very broad population of miners, you expose that decision to the broadest consensus mechanism of voting possible. I see that as a bigger concern than the 51% type of attack. Am I down the right path, or am I missing something?
So, I mean, one of the concerns with centralization is that you might see policy enforced at the miners, and if the miners are extremely powerful, and you actually get the same situation with pools, in fact, even though the pools mostly don't own their own mining resources, just because most people are not using get block templates. So the situation you have is that the mining pool or the centralized miner is a full node in the network, is looking at all the transactions, constructing a candidate block, and performing proof of work on it. And with the pools, they're doing the same thing, but they're providing the block, the hash of the block, the Coinbase, for the individual end users doing mining under that pool to work on. And that's actually a bad situation, because it means that centralization is, in the case of pools, artificially centralized in the pool operator, where there's no particular reason that the pool users couldn't be full nodes, and that's what get block template provides, actually.
Essentially, the pool operator doesn't even need to mine at all. They just need to be running a pool, and they get the vote of every participant in the pool,
right,
as long as they're not obnoxious about it and cause everyone to leave the pool. But it puts a lot of power in their hands without any hashing.
Right. So, and I think the risk that is created for centralization is kind of policy risk. So you could imagine that as mining pools which own their own hardware, or which have hardware that is leased by users on a mining contract, as they become bigger enterprises, they may be stock market listed companies or limited companies, and so they're vulnerable to court orders within their jurisdiction, and the interest to serve them a court order is relational to their proportion of power in the network. So, if somebody wanted to block a given set of transactions or a given receiving address or a given sending address or selection of sending addresses, they could issue a court order, maybe even with a gag order so that it's not clear to anybody else. So they're not allowed to talk about the fact that they're blocking these transactions. And if in a few years 90% of the mining power is in the hands of a few dozen stock market listed companies across a few countries in the world, if somebody can issue court orders on significantly more than 50% of them, they can disrupt payments. Bitcoin provides a number of interesting new features relative to the banking network. So the fact that you can't seize client assets, that you can't block individuals from receiving payments, and we saw this with WikiLeaks, as I understand it, the US government applied to the relevant department to ask for WikiLeaks to be put on an embargoed recipient list, and that was rejected. So outside of the established legal process, nevertheless, senior politicians contacted payment vendors and persuaded them outside of the law to block this transaction. So that's another example of the risk of centralization. So the credit card vendors and PayPal are in a very centralized position. So we have to avoid this kind of situation occurring in Bitcoin. And actually I made a technical proposal to combat this situation. So there are a number of things you can do about centralization. Obviously one of them is to try and combat centralization technically, to introduce diseconomies of scale or encourage users to choose their blocks when they're mining with a pool. There's no reason for the user not to be a full node, choose their own blocks, and that obviates the artificial possibility for the pool to exercise their voting power. They can exercise their voting power directly while still benefiting from the reduced variance that comes from operating through a pool. So now going back to this proposal I made to do with avoiding policy attacks from large miners. So if we imagine a situation where there are 10 mining pools in the world, they have approximately 10% each, but they're stock market listed companies and it's very easy for them to be served with gag orders and court orders and so on. And there is significant policy attack going on. They are blocking transactions and so on. So in this situation, what you want to do is to be able to transact where they can't block transactions. On the sending side, they can't block senders and they can't block recipients. And it turns out that you can do that, surprisingly. And the way that you do it is you essentially, to simplify slightly, encrypt the transaction that you would have sent onto the Bitcoin blockchain with symmetric key encryption in such a way that if it is double spent, that can still be detected. The miners validate that the encrypted transaction hasn't been double spent in the normal way, and obviously they can't because it's encrypted, they can't tell who the sender is, who the recipient is, what the inputs are, how much money is involved at that point, and yet they're still doing a partial, like a simplified validation, the expensive part of the validation, the hashing. So after, say, 6 blocks, or when the recipient needs to respend the money they've received, and the users can privately send the encryption key between them. So if I'm sending you one of these encrypted transactions, I can send the encrypted transaction on the blockchain and I can privately send you the key, or I can encrypt the key to your public key and attach it to the encrypted message, or we can just simply wait 6 blocks. So once we broadcast it, we'll wait 6 blocks or so, 6 confirmations or so, until it's been confirmed by the miners, and then we release the key to the network. And when we release the key to the network, we don't need any validation of that key because it's self-verifiable against the encrypted message. If the key's wrong, the result is garbage, the checksums fail. And so in this way, you can extract policy immunity even in a situation of centralized control. And this has been discussed under the heading of committed transactions, hidden transactions. Now, if in this situation, the miners had a very strong incentive for some reason to undo a transaction. So they learn after the fact that the transaction that they would have liked to block has gone through. In this situation, maybe they expend some enormous resources or hire some rented equipment to undo the transaction. In order to do that, they have to fight against their previous work.
So recalculating the 6 blocks minimum that have elapsed.
Right, they'd have to orphan their own previous work. Mm-hmm. Maybe if there are enough court orders, enough of these centralized miners, they can do this. It's unprofitable, but maybe a court can order them to do that, or maybe a court can pay them to do that, if they care to. That kind of partly undoes the benefit of what we're talking about. It's some cost, but they can still do it. So there's 2 things you can say about that. One thing is that you can very trivially frustrate that and make that approach completely impractical, which is that you can do it again. You can publish another small transaction every block. You can publish hundreds of small transactions every block and not reveal the keys. Every time they redo the work, you reveal another key. So basically you could stall their mining contributions. And while they're doing this, people who are not engaging in sensor resistance are moving forward on an alternative chain. So I think basically what it comes down to is that the next stage from this is that people say, well, maybe the miners will demand that encrypted transactions not be allowed, that they not be used. They simply reject encrypted transactions. But I think that's actually a technical misunderstanding, and that it's actually the end users with the wallets that decide on the protocol. The miners can't change the protocol, even though they have all the hashing power, or say a large proportion of the hashing power. All of the hashing power is slightly more complicated. But say that something like 50 or 60% of the hashing power is still in private hands. Essentially, the end users with their wallets and not the miners, private or public, privately owned as in power users or publicly listed companies. Neither or the combination of those actually has voting control over the protocol. And the reason I say that is, say that we implement encrypted transactions into the Bitcoin protocol and the miners try to vote against this at some point. Now, if they vote against it, it means they drop the transactions. And at that point, they've basically created an altcoin with no users. Mm-hmm. And the users continue with the miners that don't implement this policy.
Resets the difficulty somewhat.
It does, and that's why I mentioned that it's difficult to do that if 90% of the hashing power is in the hands of your enemy. Shall we say, in security terms, you talk about the adversary or enemy. In the case that hashing power is somewhat distributed, but geographically distributed in different countries, and some non-trivial proportion in power user or small company hands. And the jurisdictional arguments are non-trivial as well, in the sense that it can be more difficult to obtain synchronized court orders across many jurisdictions. And the mining hardware people I talked to yesterday and discussed these kind of risks with said they have shipped hardware to hundreds of countries. And they're not all sold in large batches. They're going to smaller orders as well. So it is actually relatively distributed. And so in that kind of picture, if we can maintain that picture and use encrypted transactions, it actually turns out that even though the users don't have the hashing power, they can still have the protocol control. And I think that's interesting. So it's an alternative form of defense. So if technically it turns out that we're unable to provide diseconomies of scale, or for whatever reason discourage users from using pools in a manner like using the wrong interface, using it where they let the pool do the voting, they should do it where they do the voting themselves. And there is a mechanism to do this called Get Block Template, which is offered by the Eligius pool, which has about 10% of hashing power and actually much lower fees than the other networks. I always wonder why Eligius doesn't have a much higher portion of the network. Going back to the encrypted transactions, another interesting observation is that it turns out that you can respend an encrypted transaction in encrypted form, which is kind of interesting. So if I give you an encrypted transaction, you have the key to verify the value because you can decrypt it, and so you can go back and see where it came from, a mining event or a previous unencrypted transaction where the values are exposed and the chain of custody of ownership is exposed. So you can follow that trail, but you can turn around and make a new encrypted transaction referencing your encrypted transaction as the input and get that validated. So you're spending it to somebody else, and then you provide them privately the key. So you don't broadcast the key in this case, but you provide privately the key to my input transaction and to your new transaction, and the recipient can verify the chain. So they can see that your transaction appears to be valid and it has the required value. And the inputs from your transaction, they have the key to go back and fetch the encrypted transaction that is the input, decrypt that, and then validate it. So in that way you can have a new kind of transaction privacy model, which is that only the parties to the transaction can see who sent the transaction, who received the transaction, and the amounts involved in the transaction. And you can essentially keep this up indefinitely. The only limitation, which I've not found a nice way to address so far, is that the privacy gets eroded over time. So if you imagine, 10 people are involved in this transaction chain, the most recent transaction recipient can see the entire history of transaction payments.
You can look backwards but not forwards.
Exactly. So somebody in the middle can look backwards but they can't look forwards. So there's some kind of privacy in there. Not everybody sees everything, but the latest person sees everything. And so if everybody was using encrypted transactions, payments get mixed together, eventually everybody will be able to see everything. But still, for perhaps a private group of people who are relatively close-knit, they could retain some privacy or retain a wallet that segregated addresses that were used for encrypted transactions. And I think this is an interesting and desirable, potentially, security model if we can find a way to make this work in a general sense. It retains a possibility for the conventional investigative procedures that law enforcement use, which is they follow a particular crime that they're trying to investigate and they look at external parties that interacted with the person who committed the crime. So, the car rental company, the hotel, and they will go to those entities and issue them with a subpoena for their business records. So you could see that working in this context, that we have encrypted private transactions that flow between a group of people. Some of them will be businesses that are completely innocent and uninvolved in a hypothetical crime. And they can be supplied with a subpoena and reveal the information they have and provide visibility inside this. But at the same time, phishing expeditions and the kind of mass-scale a priori network analysis of funds flows, private communications, all these kinds of things is prevented. And I think most people in society viewed that, and actually the law views that, as the correct balance for society. So, for example, many of the things the NSA has been doing with harvesting information, it seems is illegal, and even the author of the relevant law in the US has come out and
John
said...
Sensenbrenner, who said this is not what we intended with the Patriot Act, yeah.
So even the author of the Patriot Act says that the way they've been interpreting or abusing this act is not legal from his perspective, and there's a whole side story to that.
So you're providing a neat solution where the type of targeted investigative analysis of transactions is possible by finding the legal entry into the chain of transactions and compelling disclosure backwards,
right.
But only on a selective basis. But you can't scale that up to ubiquitous surveillance, thereby forcing them to revert to the original mission, which is investigating specific targets rather than all of us a priori.
That's what society authorized. All the things we see above that are unauthorized and essentially illegal actions.
Let's talk a bit about the future of Bitcoin. One of the, I think, key understandings is that Bitcoin as an invention, the combination of a distributed asset ledger with proof of work that enables both currency and many other potential applications in the future, Bitcoin as a protocol, Bitcoin as a network, can survive Bitcoin the currency, in that Bitcoin the currency could fail and we could start a different version or a new version or implement an altcoin that provides better solutions to our problems. Obviously, none of us want that to happen. But one of the arguments is that all of the cryptographic algorithms and the core mechanisms can be tweaked to generate other outcomes or to highlight different properties of the system if we find that some of the properties that were in the original implementation are not suitable.
Right. I mean, you see that argument put forward for supporting altcoins. And personally, I'm not really a fan of altcoins, and I have a couple of reasons for this. Bitcoin was a kind of one-off event, the creation of a new concept of digital virtual scarcity. So it really is a kind of digital gold, a scarce virtual commodity. And I think that it's not clear that it's desirable or good for even the confidence in the concept of digital virtual scarcity if there were to be another event where an altcoin were to take over. Mm-hmm. So I more push the view that we should add the new features that we need to Bitcoin. It can be challenging for Bitcoin itself to accept too many innovative changes too fast because they have an extremely high security bar to protect the value, which is in the $10 billion plus range now of the system. So, I mean, they have the kind of quality assurance requirements of the flight control system of an A380 Airbus Super Jumbo or what have you.
Being patched while in flight.
Yes, so you have to be really, really careful about doing that, and so they're rightly conservative with adding features. And so I tried to work out, and I think I found a plausible approach. So, I mean, they have a test net where they put bug fixes or small enhancements to have a test environment to check out things. But I think that's not quite the same thing as being able to add new features. So, for example, you notice that many of the scripting languages features are disabled so that some interesting smart contracts are not possible, and that it turns out the input values are not within the transactions. They're not within the validated part of the transaction. So it creates problems for offline wallets. Mm-hmm. They can't easily verify the values involved, and so they have to import much more data than would be necessary. So it kind of makes that complicated, so that there are actually many interesting things that could be added. And you see that in terms of altcoins focusing on adding features, so adding trading features or new transaction features. So, for example, Mark Friedenberg proposed a very nice clean set of extensions to the scripting language to support more trading functions. Very much the cleanest set of extensions I've seen, posed for sort of being able to issue an order and for anybody to match that atomically, directly, and other clear next step trading functions.
That would allow the kind of distributed exchange for Bitcoin or possibly Bitcoin into other currencies or even other types of shares that solves a big single point of failure right now, the concentrated on-ramps and off-ramps of the exchanges.
Right, so I mean you see with colored coins an approach to add new concepts by watermarking or tagging Bitcoin, so you can take a nominal value Bitcoin and attach an external value, so like a US dollar value from an issuer or a gold value from a gold depository. You have an issuer risk there, but that's implied in any kind of non-digital virtual scarcity asset, essentially, so that's unavoidable. Coming back to the way that we can move Bitcoin forward, so I think it's actually detrimental that people try to implement features outside of Bitcoin. I mean, it seems that there's a profit motive that they hope that by adding some nominal feature to an altcoin, they can mine it early, they can become very rich.
Right.
Most of the altcoins actually have no transactional volume. Literally, the blocks are empty. So from a transactional point of view, you can consider the value of a virtual currency, or actually any currency, as there's some kind of metric involving the amount of money in circulation and the velocity of that money. That gives a kind of metric of the intrinsic value of the currency. So we don't know exactly what proportion of the Bitcoin's market cap is intrinsic value versus speculative value, but clearly it has a very high intrinsic value because it provides unique functions to users, it has deployment, it has payment processors, integration, hardware, and so forth, and all of the altcoins have none of this and no transactions. I view them as sort of interesting experiments.
Laboratory. So in the future, when we look at Bitcoin, there's sort of this balance to strike between modifying, if you like, the core protocol, changing the transaction script or changing core features around mining, proof of work, etc., versus leaving that mostly alone and implementing some of these things in layers above by some of the techniques that have been demonstrated to introduce other layers of protocols within the transactions. But some of the core capabilities of the protocol, and we've been discussing anonymity and privacy in transactions, these are things that need to be implemented at the lowest level layer possible. So where do you see that balance? What do we really need to get into the core protocol before we stop messing with it and then say, from now on, really limit the amount of development? As with TCP/IP, it reached the point where it was good enough, and then we could move most of the development to the layers above and just let it ride the network effect and become more and more dominant simply through its broad utility and adoption.
Right. I think that should be the correct target, that you want to arrive at eventually core properties and essentially never change the base level after that. Unfortunately, Bitcoin has some non-ideal properties. So, for example, the fungibility layer is imperfect, which is to say the reason, and maybe people don't appreciate this, that people say that, okay, Bitcoin's an anonymous eCash system, but actually it's not that anonymous if not used carefully, and it's not that anonymous even if used carefully, or it's very easy to make mistakes, and all the values and exchanges are public. But actually the reason to have anonymity at the transaction layer is to support fungibility, which is the concept that $1 bill should be exchangeable for another dollar bill, and that if you received a dollar bill that was in the distant past involved in a crime, and presumably pretty much all dollar bills are, that as a result of criminal investigation, the dollar bill in your pocket shouldn't be seized or evaporate, right? So,
right, which is something that was resolved in the 1700s in Scotland through legal proceedings and has become part of the common law of currencies for the last 2 centuries.
Right.
And yet in Bitcoin we're having this discussion at the moment of blacklisting and whitelisting and redlisting and various types of filters, destroying the fungibility. I see this as an extreme threat that could effectively be an extinction level threat to Bitcoin if implemented, because it would shift the power from the 2 parties involved in the transaction to a third counterparty that controls the list.
Right. It seems to stem from a misunderstanding about where Bitcoin gets one of its main core advantages. So one of Bitcoin's main core advantages is that it's immediately and instantly settled. So it's an irrevocable payment. And that reduces the traditional costs of arbitration, fraud management, So you see with credit cards, due to arbitration and fraud management, they have fees in the sort of 3 to 5% plus 50 cent plus per transaction, and PayPal has perhaps some kind of similar cost structure because they also have to handle the same kinds of issues. So as I was saying, there's a very clean transaction layer which is kind of mathematically perfect. If you introduce dispute arbitration into the transaction layer, you introduce costs into it. Immediate final settlement goes away. Now merchants have to buy insurance or engage escrow parties to do arbitration, and none of these things are free. So at that point, Bitcoin's transactional cost advantage will disappear. And
Right.
there'll be no transactional cost advantage versus credit cards.
The BitGive Foundation is a non-profit charitable giving organization leveraging the power of the Bitcoin community to improve public health and the environment worldwide. Help us demonstrate the significant impact of Bitcoin in addressing these critical issues on a global scale. Support international giving in Bitcoin. Please visit our website at www.bitgivefoundation.org. That's www.bitgivefoundation.org.